Alright, I'll take you through the strategy of solving 4.4, which is a horizontal mass spring system. So we start off with the mass in a spring. The mass is 2 kilograms, and the spring constant is the first question we have to answer. We don't know the spring constant, but we know that if we pull this mass back to 0.05 meters, the force required to get it to that level is 10 newtons. So we can use Hooke's law to find K. And Hooke's law is just simply the restoring force in a spring is negative K, which is the spring constant, times X. I'll leave you to work out the actual number, but the spring constant is just the force divided by X with a minus sign. So that's the first question. The second question asks us to find the period. Well, we know that in general, omega is equal to 2 pi over t. But for a mass spring system, we also know that omega is equal to square root of k over m, where k is the spring constant. To find t, we just equate these two to equal to each other, and we have our answer for the period. The third question asks us to find V max. So this one you have to use a little bit of thinking to figure out. If you look a little bit above in your worksheet, you'll find the general equation for velocity as a function of t. I'll write it down here, but it's minus the amplitude times omega times sine omega t plus the phase angle. So we know that sine omega t plus phi is maximum at either minus 1 or plus 1, and V max will be maximum when sine omega t is minus 1, so this minus sign gets cancelled out in front of the amplitude. So we've left with V max is equal to A omega. To find A, you just have to look back at the diagram that you drew and realize that the mass oscillates from minus 0.05 meters to plus 0.05 meters. So the amplitude is 0.05. So that's it. If you break up the mass spring problem into several steps, you should be able to do almost any mass spring problem. Okay, that's it.